Hello everyone. Today we're going to be looking at applications of linear functions. There are 4 questions we're going to go over today, and we're going to go do something slightly different today. I'm going to get you to actually pause the video in a moment, and I'm going to get you to work through these questions on your own. And once you've completed the questions, you can unpause this video, and I'll just go over the solutions really quick. They should be fairly straightforward. I mean, it's just answering basic questions with linear relations. Sort of the trickiest thing, I guess, is going to be maybe writing an equation in slope y-intercept form, which I think you're all capable of doing. So hit pause, and in like a second, I'm going to go over the solutions to this really briefly. Okay. So here we go. What is the horizontal or T-intercept? What does it represent? So the T-intercept happens down here. So that is at 10, 0, and that's the touchdown. So I'm going to get you to mark this actually. This first page will be at a 5. So give yourself a mark if you've got, you might have just put 10 down. That's fine as well. What does the point represent? Something like touchdown, right? So the plane is landing and it reaches 0 height at 10 minutes. Okay. The vertical H-intercept is this 0, 1,000. You may have just put 1,000. That's the height before they started descending, or potentially the height that they started recording their elevation as they were dropping. Okay, the domain and range, there's the domain, so we go between 0 and 10. So the domain again covers the possible values for the independent variable, and the range is that, so between 0 and 1,000. So the dependent variable can go between 0 and 1,000. Now, you may have opted to do instead sort of the, let's see here, this slightly different version. So you might have just put domain like that, and that's totally fine. This is kind of a little bit more formal, but if you just put something like that down, that's fine as well. So go ahead and give yourself a mark if you got that as well. The rate of change for the graph, and what does it represent? So we need to just calculate the slope. In my case, I chose these 2 values to figure out what the slope was. So we just need the rise and the run, so going like that. So the rise, you go from, I guess that's 500, so we drop 300, and we go for 3 minutes. So rise is negative 300, run is 3. 300 divided by 3 is negative 100. So more formally, I've got it written out here. So those are my points that I chose. You get there, negative 300 divided by 3, which is negative 100 meters per minute. So that's their rate of descent. I don't know if I put anything there, that's it. Okay, the equation of the line in slope y-intercept form, we've just figured out the slope. The y-intercept is 1,000. Just making sure to write the equation in terms of the variables as written. So we're not going to be using x and y. Instead, we'll be using t and h. So you should have something h equals so on. So that would be your equation. All right. So give yourself a mark for that. First page there out of 5. Moving on. The graph here shows temperature as a function of time in hours. What's the horizontal intercept? It's there. So that is the time when the temperature is 0 degrees Celsius. So 4, you might have just put 4. That's fine as well. Some kind of interpretation, also good. So mark for that. What's the vertical T-intercept? So that happens there. That's the temperature at the start of data collection. So it's a bit hard to tell when they decided to start collecting data. So what's 0 hours represent? Like, is that midnight, or, hard to say. Maybe at sunrise, so just at the start of the data collection. Domain and range, so there's the domain and the range. So we can go between 0 and 12 for the independent, and -5 to 20 for the dependent. Did I write 20? No, hang on. We only go from -5 to 10. My mistake. So, yeah. And obviously, if you wanted to write that in a more formal version, you're welcome to that as well. You just have a set of curly brackets. And so, for example, this one, you would have all t such that t is between 0 and 12. And I guess if you really wanted to get specific, you could say that t is an element of real numbers. Okay, and then similarly, you just have kind of the same format for the other one, if you want. This is, I think, contains all of the most important information. So I would rather you write it in this format and have the domain actually correct than worrying about all these curly brackets. So mind you, it's not that much of a different format, but yeah, let get you to focus on, actually getting the domain and range correct. So that, I think, is more critical. All right. What's the rate of change for the graph, and what does it represent? So you can see I've chosen 2 points here. So I've got 4, 0 and 0, -5. So that'll be my x2, y2, x1, y1. So based on those values, I've got that, and there, and 1.25 degrees Celsius per hour. So go ahead and give yourself a mark for that. And last up on this page, so we're just going 1 mark per question for each of these. So 1 mark for part A, 1 mark for part B, and so on. And there's the equation, 1.25t minus 5. Now, if you decided instead to write it as a fraction, that's totally fine as well. 5/4 t minus 5 is perfectly acceptable. Actually, it's probably preferred, but either one is fine. Okay, that page is out of 5. Okay. So next, Sam is driving back to Calgary. His distance from Calgary is given by the linear function d equals -80t plus 240, where t is in hours, since Sam started driving. Never mind. Okay, so the D-intercept, or I guess the Y-intercept, so it'd be like y equals mx plus b. B is your intercept for the dependent variable. So you can just read it right off of the equation. It's 0 to 40. And the T-intercept, so sort of the x-intercept if you prefer, where does that happen? When d equals 0, right? Okay, so we just basically put d equals 0 into this equation and then solve for t. So as a start, we would have here 0 equals -80t plus 240. I can bring this -80 to the left side of the equation, so we get that. -80, so it's +80 to both sides. And last, to get t on its own, we divide both sides of this by 80, and we get t equals 3, so 3 hours. Or I guess you would have 3, 0. So go ahead and give yourself 1 mark for that and 1 mark for that. So that one's out of 2. Next up, the graph. So use the intercepts to sketch the graph. We have 0 to 40 there and 3, 0 there. Connect the dots. You should have distance here. You should have time there with units as well, units there. And one more thing you should have is probably a title. It's usually a good thing to include. So go ahead and maybe give yourself a half mark for each element. So if you've got a title, half a mark. If you got a line that's straight, give yourself half mark for that, including units, half mark for that, including units. So grand total for that one, make it out of 2. Moving on, what does the horizontal intercept represent? So that's there. That is when they reach their destination. So Calgary is their destination, right? So they started off a distance away from Calgary, and they got closer and closer to Calgary, and once they reach there it is. Okay, vertical intercept is the distance from their destination when they started. So I don't know where that would be physically. I think it could have been Wetaskiwin. You can maybe search that up on Google Maps if you want. Okay, so that's that. So each of these out of 1. Domain and range of the function. So domain is that, and the range is that. So between 0 and 3 hours is the domain, 0 to 3, and between 0 and 240 is the range. Okay, the slope of the line, so we can just use, I guess, the endpoints that we used. So 0 to 40, and well, maybe I'll just write those out. So 0 to 40, and 3, 0. So those will be your, you can do x2, y2, that'll be your x1, y1. So go ahead and plug those into the formula, right? So you get there. And so that would be negative 240 over 3. So there we go. And then simplify that a little bit more. So negative 80 kilometers per hour. And what does that represent? It represents their speed. So give yourself a mark for that. Grand total, this page would be 2, 4, 5, 6, 7, 8. So that one's out of 8. And last page here. Okay, we've got a linear function that relates cost to the number of people attending. Okay, using our graphing calculator in the window to sketch the graph of the function. So I didn't quite do that, but that's fine. What I did instead was the cost at when the number of people is 0. So 25 times 0 plus 1,000. I mean, I guess you could read it off the equation too. This is 0, 1,000. And up to here, so as given 300, so t should be 300, or sorry, is it tn? So I put 300 in there, or is it 200? Yeah, it's 200. So 25 times 200 plus 1,000, that gets you to 6,000, so this would be 200 and 6,000. Now, if we wanted to graph this in our graphing calculator, it gives us window settings. I can't type it in as it is here because the variables aren't accepted by my graphing calculator. So I gotta go like this instead. So I'll put this in for y1. Let's maybe see if I can bring that up. Hopefully it'll wake up for me. Come on. There we go. So, okay, 25x plus 1,000. Okay, if I graph this, nothing's going to show up. Why? Because my window settings are incorrect. So how do I fix that? I need to adjust it as given here. So to do that, I click Window. My x min would be 0. My x max as given 200. So 200. X scale will be 5. Y min 0. y max 6,000, and y scale is 1,000. Now when I hit graph, hopefully something comes up. There we go. So that looks like what I have here. And if you wanted to, right, you could figure out the value down here. I mean, you could read it off the equation, but suppose you just wanted to confirm or something. So x0 is 1,000, and we can just double check that I got this right. So value when x is 200, 6,000. Okay, so good. So we've got confirmation that this looks good. So we should have a title, banquet cost, something like that. It doesn't have to be exactly like that. You could do cost versus number of people. That's probably a safe choice. Have the vertical axis labeled with units. You need the horizontal axis. Number of people would be fine. So half a mark for that, half a mark for that, half, half. So grand total for that question out of 2. Okay, next, what's the slope and what does it represent? So we can use our endpoints here, right? Plug that into the equation. So slope is that. So 6,000 is the max y value, and 1,000 down here. 200 is the max x, 0 down there. 6,000 minus 1,000, 5,000 divided by 200, and then simplify, $25 per person. So that's like the cost per person. All right, and last, what's the vertical intercept and what does it represent in this model? So we're there. That's the vertical intercept. So it is 0, 1,000, and it's the cost to rent the venue. Okay, so that page, what's that out of? We've got 2, 1, and 1, so that's grand total out of 4 for this page. So 5 and 5, 10, plus another 8 is 18, plus 4, so grand total will be out of 22. If I could just get you to let me know how you did on that. I hope you did quite well. I think it's, yeah, good practice for you. All right, so to summarize for the day, the slope of a line always represents the rate of change. The x-axis plots our independent variable, and the y-axis plots our dependent variable. In general, the domain describes possible values for the independent variable, and the range describes possible values for the dependent variable. So the x-intercept tells us when y equals 0, and the y-intercept tells us when x equals 0. All right, so that's it for the day. See you next time. Oh, also, probably a good idea to get started on some review questions. And now that's it. Okay, see you next time.